So guys, welcome to our channel once again. In today's video on our WAEC physics exam revision series, we have here these 5 WAEC repeated questions to answer on the topic equilibrium of forces. So guys, this video will be about the principle of moments. So in short to say, till the end of this video. So let's quickly go ahead and start with the first question here. It says, a uniform bar 15 meters long is balanced on a pivot placed at its midpoint. A boy of mass 55 kg sits on one arm of the bar at 0.5 meters away from the pivot. What mass can be placed at 2 meters away from the end of the bar to keep the bar horizontal? Guys, we are going to tackle this together. So guys, the first thing we are going to do here is to sketch out this diagram. So let's say the uniform bar is this way. So having the uniform bar here, it's 15 meters long. So being 15 meters long, if you place the pivot point here at the midpoint, that's going to be like 7.5 to the right, 7.5 to the left. So we have this in 7.5 to the right and 7.5 to the left. But let's also recall that clockwise moment is also equal to the anti-clockwise moment. So if 7.5 to the right here, and this boy has a mass of 55 kg and he's placed to 0.5 meters away from the pivot point, that will be this here at this point. So that will be 5 meters from the pivot point. So to the end, you will just have 2.5 meters remaining to the end. So this will be that mark 5 meters here has a mass of 55 kg at that. So for the left part of this, we said what mass can be placed at 0.2 meters from the end of the horizontal bar, from the end of the bar. So we are going to have that from the point here, from this initial to this point is 2 meters. So if this is 2 meters, it means that we'll still have 5.5 meters here to complete the 7.5 meters. So the mass will be placed here. So let's say the mass is m. So with this diagram, we already know that the mass 55 kg is 5 meters away from the midpoint. So whereas the mass m is 5.5 meters away from the midpoint. So in that case, m times 5.5 is equal to 55 times 5. So if we go ahead and make m the subject of this equation, we're going to have m is equal to 55 times 5 over 5.5. So guys, if you go ahead and calculate this, you're going to have 50 kg. And that's option B here, guys. So option B is the answer to this question. Let's go ahead and consider the next question, guys. So question number 2 here says, two forces, 3 newtons and 4 newtons act on a body in directions due north and due east respectively. Calculate the equilibriums. So guys, if we use this triangle formula, we are going to have, let's draw this as a triangle where 3 newtons is for north and then 4 newtons is for east. So if we complete this triangle, we're going to use a Pythagoras rule where 3n squared plus 4n squared will give us the z squared here. Let's say this is z. So z squared is going to be 9 plus 16, and that's 25. So z alone is going to be root 25, and that's 5. So the resultant force here will be 5. And considering this triangle, we're going to have that tan theta here will be opposite over adjacent, where the opposite here is 3 and the adjacent is 4. So guys, theta is going to be tan inverse of 3 over 4, and that's 37 degrees. So in that case, option B becomes the answer to this question. That's 5 Newton, 37 degrees north of east. So that's it for this question. Let's go ahead and consider the next question, guys. So here, the next question here is question number 3. It says, an object of volume 400 cm cube and density 2.5 gram per cm cube is suspended from a spring balance with half its volume immersed in water. Determine the reading of the spring balance. So guys, let's go ahead and calculate for this. Since density is mass over volume, then mass is going to be density times volume. So guys, density here of the object is going to be 2.5 grams per cm cube, and then the volume is 400 cm cube. So guys, in that case, we're going to have 2.5 cm cube times 400 cm cube, and that's going to be 1000. So 2.5 gram per cm cube times 400 cm cube is 1000, and that's 1000 grams. So the mass of this is 1000 grams. So we're also going to check for the parts immersed in water. So since the density of water is 1 gram per cm cube, we're going to have that the mass for this part is going to be 1 gram per cm cube times half the volume, that's 200 here. So that will be 1 gram per cm cube times 200 cm cube, and this will give us 200 grams. So guys, if we do 1000 grams minus 200 grams, we are going to have 800 grams, and that's option A here. So the mass of this object here, as shown in the spring, will be 800 grams, and that's it for this question. Option A is the answer. So let's go ahead and consider the next question, guys. So guys, the next question here is question number 4 here. It says, a uniform bar AB is placed on a knife edge which is 60 cm from B by a mass of a uniform bar or AB is balanced on a knife edge which is 60 cm from B by a mass of 22 grams, which hangs at C 10 cm from A as illustrated in the diagram above. Calculate the mass of the bar. So guys, we are going to draw this diagram here first of all. So putting this is A and B, and then we have the knife edge at 40 cm. So we have this suspension of mass 22 gram at 10 cm from A. So alright, so now that we've gotten this, the next thing we are going to consider is the distance of the masses from the pivoting point where we have the knife edge. So Now, since the mass here is 10 cm from A, it means it's going to be 40 minus 10, that's 30 cm from the midpoint. So guys, that's 30 cm here. So it means that the clockwise moment is going to be 30 times 22. So remember that the clockwise moment should be equal to the anti-clockwise moment. But then, since this bar is a uniform bar, it's going to have its mass centered at the midpoint. So the mass of the bar is going to be centered at the midpoint, which is 0.50. So since it's a bar of 100 cm long, the mass is going to be centered at 0.50. So that will be 50 minus 40, that's 10 cm from this pivoting point. So we're going to illustrate this. The mass is going to be 10 cm from here. So let's call the mass m. So it means that 10m is equal to 30 times 22, or let's say 30 times 22 is equal to 10m. So m alone is going to be 30 times 22 over 10. So guys, with this we have 660 over 10, that's 660 grams over 10, and that would be 66, and that's option A here, guys. Option A is the answer to this question. So let's go ahead and consider the next and last question, guys. So the last question here, question number 5, says the basic principle of operation of a beam balance is A. Hooke's law, B. Archimedes' principle, C. Principle of moments, D. Law of flotation. So guys, obviously the answer to this question is option C, and that's principle of moments. So guys, this is where we'll end this video for today. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop a question in the comment section below, and we'll be sure to give you a response. Finally guys, we want to encourage you to join our YouTube channel community where we post major updates on WAEC examination. This will help you a lot even as you prepare for your WAEC examination for the year. So you can join this community by hitting the join button below, and we'll see you right there. Thank you once again for watching this video, and see you on the next one.